Product of two vectors. Multiplication of two vectors is defined in two ways, namely scalar or dot product where the result is a scalar and vector or cross product where the result is a vector. The scalar product of two non-zero vectors, vector A and vector B, denoted by vector A dot vector B, is defined as A vector dot B vector is equal to modulus of A vector into modulus of B vector into cos theta, where theta is the angle between the vectors A and B. Observations. A vector dot B vector is a real number. Let A vector and B vector be any two non-zero vectors, then vector A dot vector B is equal to 0 if and only if A vector and B vector are perpendicular to each other. If theta is equal to 0, then A vector dot B vector is equal to modulus of A vector into modulus of B vector. If theta is equal to pi, then A vector dot B vector is equal to negative of modulus of A vector into modulus of B vector. For mutually perpendicular unit vectors I cap, j cap and k cap, we have I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap is equal to 1 and I cap dot j cap is equal to j cap dot k cap is equal to k cap dot I cap is equal to 0. The angle between two non-zero vectors, vector A and vector B, is given as cos theta is equal to A vector dot B vector divided by modulus of A vector into modulus of B vector. The scalar product is commutative, that is A vector dot B vector is equal to B vector dot A vector. Let A, B, C be any three vectors, then A vector dot B vector plus C vector is equal to A vector dot B vector plus A vector dot C vector. Let A and B be any two vectors and lambda be any scalar. Then lambda times A vector dot B vector is equal to A dot lambda times B vector. If two vectors A and B are given in component form as A1 I cap plus A2 j cap plus A3 k cap and B1 I cap plus B2 j cap plus B3 k cap, then their scalar product can be defined with the help of the properties of mutually perpendicular unit vectors as vector A dot vector B is equal to A1 B1 plus A2 B2 plus A3 B3.